Aryabhata 1.0, which is LLM focused on JEE Math problems, and they have gotten a higher score on like even O4 Mini and Gemini Flash proprietary models. So unfortunately, Sachin couldn't come today because of some urgent reasons. But Soumik from his team, he's a ML engineer there, and he'll be presenting today. And this talk is going to be about LLMs, agents, and startup life. So basically, just to give a short intro about what this is. So as we know, like LLMs are everywhere in Gen AI right now. But what is the secret ingredient for those capabilities? Like as we all know, so that is reinforcement learning and post-training of LLMs. So AthenaAgent focuses on post-training of LLMs and also other stuff as well. And just to give a short intro about Soumik, so he has worked at RoboFlow, which is a company which focuses on computer vision models, and he has a lot of experience in ML ops. He has worked at Weights and Biases, if you have heard of them, and he has also experience at IBM. And right now he's working at AthenaAgent on LLM post-training and even diffusion models. So yeah, Soumik, can you turn on your cam?
Is my camera visible?
Just a minute. Uh, yeah. पिन कर दे उसको. Yeah, just 2 minutes. Yeah, we can start now. Thanks for
Amazing.
joining, Soumik.
Thank you. Thank you very much. So, hi everyone. I'm Shomik. I'm an ML researcher at AthenaAgent, and today we will talk about a lot of things: LLMs, agents, and what startup life is about. So, a little bit about myself before we start. So, I'm currently doing research at AthenaAgent, mostly on post-training recipes for foundation models, including LLMs and diffusion models for image and video generation. I have served as an ML engineer and researcher respectively at Weights and Biases, RoboFlow, and IBM previously. I have spent the last 6 years almost working on computer vision, ML ops, and diffusion models. And I'm also a Google developer expert in the JAX category. And in my free time, you might catch me playing the violin or playing Soulsborne games on my PS5. So we are, at Athena isn't one of our biggest achievements in the past couple of months has been the release of Aryabhata 1.0. So it's a 7 billion parameter large language model that has been trained specifically for solving JEE mains and advanced mathematical questions, and not just solve and give a correct answer, but also to provide the reasoning traces and step-by-step solutions for solving these problems so that they can be used for pedagogical reasons. And we have basically developed this model in collaboration with PhysicsWallah, and you might all know about PhysicsWallah. So what's so special about this model? So the best thing about this model is it's highly efficient in terms of the compute that we used. It's highly efficient in terms of the token budgets, and it's also highly accurate, beating most state-of-the-art frontier models. For example, GPT-4 Mini, it has beat 4.0, obviously. It has beat Gemini Flash 2.0 and 2.5 on by scoring 90.2% on the JEE Mains April 2025 set. So it has basically outperformed some of the best models that we have currently on solving JEE exam style tasks. So that's the USP of this really good model. So if you can see, I'm not sure if this chart is super high resolution on the screen or not, but as you can see, like Aryabhata is basically derived from a couple of open source models, including 25 Math 7V, and how clearly it basically beats all these models, including GPT-4o, GPT 4.1, O4 Mini, Gemini, DeepSeek, on the JEE Mains mathematical reasoning problem. So we are a narrow intelligence lab, and a lot of the time we are working on large language models. So let's just try to understand what are these large language models. So think of them as basically learning models with a lot of parameters of the order of several billion parameters that are trained on huge data sets, mostly that are derived from the entirety of the internet. So these models, they can basically be accepted as an accepted reasoning model for human knowledge, human language, and can basically understand linguistic nuances, can act as generalized reasoning engines. So LLMs do basically, why large? Like that's one of the things. Why not small language models? So the thing is, basically it has been noted that when you keep scaling up with respect to the number of parameters in a machine learning model, and also when you have huge amount of data that you want to be represented by a certain number of parameters, these certain abilities like summarization, being able to solve coding problems, math problems, or being able to reason, these are certain emergent abilities that has been observed when you are scaling up, both in terms of the number of parameters of a language model and also in terms of the volume of data that you are training the model on. So you can basically think of large language models as the foundation layer of modern AI applications. That be it you are using something like Cursor, they are also being powered by a large language model. If you're using some kind of AI search application like Gemini or even Perplexity, they are also being powered by these kind of models. So language is just one aspect in which these models are basically speaking to us, but there are also multimodal language models which can understand images, which can take images as input, which can take audio as input along with text and give us the output in text. So this is broadly what language models are about and why they are so large, why we need these really large language models. So I wanted to talk a little bit about the timeline of the development of LLMs and where we got from where we started. So, in 2017, the original Transformers papers came out. It was by Ashish Vaswani in Google, and the paper is "Attention is all you need." So I really recommend you guys go ahead if you're wondering what's my starting point into this world of AI and LLMs. I highly recommend that you folks should go and check out the original Transformers papers. It's "Attention is all you need." These transformer models are basically considered as they are used as the building blocks for all kinds of AI models. So be it encoder only models like BERT, which came out in 2018. So BERT-like models are really something which made NLP way more accessible for developers. So what they are, think of them like masked language models. So what masked language models do is they have an encoder which encode a certain amount of data into a hidden latent representation, and a decoder which is trained to recreate these latent information into the actual text. So it's very similar to an autoencoder. So if you know what an autoencoder does, that's really what bot-like language models are. So the way these language models were trained, BERT-like language models, they are trained by, they are trained in a bit of a fill in the blanks manner. So instead of predicting the next token, you just mask some of the tokens in between, and then basically the model has to predict what's in between. So it's very similar to Kai-Ming Hay's formulation of masked autoencoder, which is used in a lot of diffusion models like Flux right nowadays. Uh, so these languages basically are really good at contextual embeddings of models, and these models are really useful for tasks like downstream applications like classification or any kind of regression based applications, or if you want to do anything like search. So for example, in retrieval augmented generations or modern agentic applications, if you are using search, but like applications, but like models are basically really useful. So then basically, we come to the GPT style model from OpenAI. And GPT-1 to GPT-3 was basically a demonstration of the chinchilla scaling laws. So the more you scale up in terms of data and the number of parameters, essentially, the better performant your models start becoming. And then basically we in 2022 we basically had the breakthrough moment in NLP, which literally revolutionized the domain of machine learning forever. Chat GPT came out, which was one of the first ML powered products which saw such mass adoptions in B2C domains. So the best thing that basically or the thing that really made ChatGPT different from previous models was that like GPT 1, 2, 3, it basically could predict the tokens corresponding to your user prompt, but it felt like you could finally have some conversations with a language model for the first time. So you can think of it as one of the first useful chatbots in the history of machine learning. So that's basically what ChatGPT gave us. Basically, user aligned conversations. You could really have a conversation by considering it as an entity, and the way it achieved that is using something called reinforcement learning with human feedback. So uh, nowadays, post-training recipes like direct preference optimization, policy proximal optimizations, GRPO, etc., they are basically much more advanced algorithms for post-training or user alignment of how an LLM speaks or how an LLM reacts to a particular query, and that all started, let's just say, with ChatGPT. And then coming to the next year, we the biggest breakthrough we really got was the dawn of reasoning models and multimodal inputs. So we started seeing that GPT-4o and other models like GPT-4 Turbo, the entire GPT-4 series of models, they could understand images, they could reason. So reasoning was one of the chain of thought style reasoning was one of the biggest breakthroughs in that particular year, because previously the models were basically acted like stochastic parrots. They would just predict the next token, and most of the times it made no sense. So you had to manually prompt it to think step by step. But since 2023, basically the thing about reasoning models is that things like O1 or even Sonnet, Cloud Sonnet 3.5, they could basically think first and speak later. So they would first predict these reasoning tokens based on which the actual query would be answered. So that's Aryabhata is also a similar model. If you think of the JEE, if you think of the problem of solving a JEE mathematical question step by step. So yeah, so the entire boom of reasoning models came in 2023, and since 2024 or since the later half of 2024, we are basically seeing the dawn of specialized reasoning agents. So if you have used tools like Cursor, if you have used tools like Windsurf, Lovable, or any other similar kind of tools for applications like to fix a bug in a particular code base by using multiple reasoning steps, or speaking orchestrating different tasks, or reasoning to basically solve certain tasks or give you some certain structured outputs which could be used in a downstream application. That entire thing is basically what we are chasing after right now. Better models which can better reasoning models which could be used to build specialized reasoning agents, just like Cursor or Windsurf. So okay, let's talk a little bit about reasoning. So uh, earlier, basically, I used a very controversial statement that previous generation of non-reasoning LLMs acted more like stochastic parrots, in the sense they would try to basically answer your query by something called memorization or pattern matching. So if you are basically if you have the question hidden in the query itself, So let's say you want to understand something about a document. That's very straightforward. You just need to look for it and just find the answer. These language models like GPT-4o and all, they were really great. But when things came to solving problems like, finding where the bug lies in my code base or how do I solve it, it's a multi-step reasoning problem. And think of reasoning as something which we humans are inherently pretty good at. We don't just jump into conclusions randomly just by taking a look at the problem. We think step by step. So we first maybe if we encounter a bug, we first take a look. Okay, so which file this was basically? We take a look at the trace and see which source code files these bugs are coming from. We try to localize the problem. Then basically we backtrack and try to figure out what went wrong, what could have gone wrong, which could have gone wrong. So reasoning is basically a logical step-by-step chain of thought, which we humans are pretty good at. But since the human brain is also kind of like a stochastic engine, so at some point, basically the brain might get tired, and that's why models or machines which can reason are something which have been really useful, and a lot of people are using it. So the core forms of reasoning are basically, four. That's deduction, which is, you apply a rule to reach certain conclusion. You do not jump to the conclusion, but you deduce the conclusion. There's induction, which is learning from examples to generalize. So if I want my model to output the or structure the output in a certain manner, I can basically show it. Okay, you must structure it like this, or you must answer it like this. And it basically learns by induction. So think of strategies like few shot prompting, which many of you might be familiar with. So induction is something like that. Then there is abduction. So when we basically try to solve a problem which we have encountered, we try to basically explain why something happened. So abduction is basically that we find, okay, what could have gone wrong? This could have, thing A could have gone wrong, B could have gone wrong, C could have gone wrong. Then we basically match each possible scenario with the evidence we have available, and the one that's closest to the evidence is basically something which we usually go forward. So at our chain of thought logical reasoning step, there are multiple possible branches which one can take, but we take a certain very not so stochastic path. So that's basically called abduction. And then there is planning. So given that I need to perform a certain task, I need to plan ahead. So first I'm going to solve problem number A, then I'm going to solve problem number B, then I'm going to solve problem number C. We just, whenever we have a, let's say, whenever we have a software engineering project, we just don't jump and start writing code, right? We have some planning. We plan whichever whatever kind of problem it is, be it coding, be it navigating the real world. We plan ahead. You all plan ahead for your future. We plan ahead financially. We think of our the what could be the possible scenarios that are coming later into the future in a future time step, and accordingly we basically plan. So planning and adapting is something which is essential to reasoning as well. So why do we need these reasoning models? Why can't we just be grateful that the previous generation of stochastic parrots exist? Well, so some of the things I already discussed. So generalization is one of the problems. So if you basically leave a human in a in an environment they had never seen before, they would find ways to adapt. They would find ways to survive, and that's something called generalization, which is the adoption of unseen tasks or unseen environments which the agent probably doesn't have any knowledge of. So uh, there are a lot of components into that particular kind of scenario. There's uncertainty, right? Because let's just say if I do not know where things are in this room, I'm sitting in a room. If I do not know where things are in this room, I'll try to think step by step. Maybe I'll try to plan ahead and basically uh, make some chain of thought reasoning that, okay, so there's a wall blocking this place, so I might go circumnavigate the wall instead of running directly into the wall and stuff like that. So it's not just really useful for things like complex logical reasoning tasks like solving mathematical problems, solving problems of physics, solving problems with respect to software engineering and computer science. But it's also if you want to build agents that can be interfaced with real life robotic systems, be it I'm sure you folks have heard about Hugging Face's latest robotic interface called Lerobot and stuff like that. So to navigate the real world, because the real world is so much stochastic, so much filled with uncertainty, we need agents that can basically dig itself out of a hole if it ever encounters such a scenario. Then it has to be reliable in the sense that, if I ask the same question 5 times, it has to give me it can take different logical reasoning approaches, but the answer has to be same. It should not be hallucinating, and hallucinating has been a huge problem of the previous generation of models because it's just predicting without any reasoning traces. And then again, as we discussed, like we are living in the age of agents. So these large language models or these reasoning models are basically going to act as the foundation models for autonomous agentic systems, which automatically plans for us, automatically knows which tool to use when, and essentially, basically, they can plan ahead for themselves and manage themselves and operate in the real world or in a virtual world, whichever you prefer. So I have been using this word agent for a long time. In fact, the word agent is there in the name of my company. But what really is an agent? So let's just think of an agent like this. It's anything that can react, that can perceive a stimulus and react to the stimulus or act on the basis of that stimulus. So you all are agents. You all are naturally evolved agents. We humans are naturally evolved agents. But today we are basically discussing about these large language models which can act as agents to complete certain tasks. So these agents, you just tell them, hey, I have encountered this bug. I don't know how to solve it. You just figure out however ways you can solve this. So this agent also has to think like us to basically be able to solve this task. So it has to plan. It has to think in steps. It basically has to use tools, and based on the environment or the kind of task, it has to adapt. I really recommend that you read this amazing blog by Lilian Wang, which Sachin has linked here. So this is a really nice blog post. But essentially speaking, if you have to boil it down to the most basic of the coding or engineering concept, it's just calling a few LLMs which has access to tools inside a for loop until and unless the task is solved. And that's all basically agents are. These tools, what these tools can be, essentially, if you are building a coding assistant, it can be tools like giving it access to your code base files, being able to execute commands on the terminal, being able to get access to log files automatically when it decides. So you can also have generalized agents. So ChatGPT is kind of like a generalized agents. There are platforms like Bhindi AI, which are basically letting you add more agents or tool sets to the arsenal of the agent. So you can give it access to your calendar, and it's going to basically plan your events or plan your itinerary if you're going out to visit somewhere. It can take decisions based on what it has done in the past and how it basically take that memory into account while making a decision in for the future and stuff like that. So that's literally what an agent is. It's basically LLMs with memory inside a for loop. And agents are not something new. Like they're not just. Of course, we are able to see agents at work in the recent times, but that doesn't mean they have just come around this time. In the pre LLM or the pre ChatGPT era, we had a lot of research that went into reinforcement learning and how we can solve tasks using virtual agents, like play Atari games, play games like StarCraft, Dota, Minecraft, etc. So reinforcement learning has been powering agents, let's just say, since the early days of deep learning research. You must have heard of Google's research into AlphaZero and the AlphaGo models, which basically beat the world champions in Go. Uh, so that's kind of the thing. since 2020, we have tried to basically create LLM agents when basically we figured out that we can actually formulate function calls or tool calls using just natural language. Uh, it was a nice way of building agents. It's a much more simpler way of building agents, but reinforcement learning is still pretty important to this new category of agents. It's because you still want your agents to learn to handle uncertainties and outliers which it might not have encountered in the data. So learning a generalized policy is really important for agents so that they can solve certain tasks. So nowadays, the agentic environments or the ways to benchmark agents actually has shifted from the whole simple games like Minecraft or Atari games, and like we are literally testing agents right on our computer using Docker containers. Like you must have used Cloud Code, you must have used Cursor, and all of these are basically agents which are actually helping you out in your day-to-day life. So that's kind of all I wanted to talk about our life, about our work, the introduction to the world of LLMs, agents, and transformers. And I'll just talk a little bit about the kind of work that we are doing at AthenaAgent and the kind of work that I personally have done in the past. So it's kind of like I'll just talk about my experience. So first, a little bit about my journey. So I did my BTech from KIIT University in Bhubaneswar. Wonderful, met some wonderful people there. Tried to launch my first startup, raised some capital from Nvidia, but failed miserably. Then joined IBM as a software engineer, moved into NLP research for a while, and then I joined Weights and Biases in 2022. You folks must have heard of Weights and Biases, or 1B as it's more popularly known as. I was part of the team that basically took Weights and Biases from that eventually led to the acquisition of Weights and Biases by CoreWeave. And as part of Weights and Biases, since over the last couple of years, I developed tools for observability in LLMs, built tools for machine learning and computer vision practitioners, solved real life machine learning problems, helping out different customers. And I mostly had a background focusing on computer vision and radiance fields. So it's still kind of computer vision, but in some portion it leaks into photogrammetry. So I built a lot of tools around these domains, integrated weights and biases into a lot of open source libraries. For example, Keras, I Ultralytics, then MonAI, and a lot of other computer vision tooling. Basically, I worked on. It was an amazing experience. Uh, so since then, basically, I joined briefly uh, a San Francisco-based company called RoboFlow. You folks must have heard of RoboFlow from the amazing work that's being done by Piotr Skalski and his team. So I worked with them for the last 4 months to launch some open source repositories, which try to make computer vision-based multi-object tracking accessible to all developers. And the work is ongoing. But right now, I'm working with Sachin and his team at AthenaAgent to basically, bring frontier models or specifically speaking, narrow intelligence accessible to all Indian businesses and the public in general. So, we at India, we do not have the same resources that a San Francisco-based company or the companies that are based out of Japan or Europe has. But in spite of not having those resources, the best strategy we decided to take is that instead of competing to or racing towards AGI, we are going to build ANI or artificial narrow intelligence and make sure that these large language models or the foundation diffusion models or vision language models, all of these foundation models, they are accessible to all businesses for they can be used and make sure that these models can be used for any applications regardless of whether the original trained model knows about that application or not. So that's one of the ways we are trying to make AI accessible to not just India but to humanity at scale. So it's not easy. I wish I could say it was easy work, but it's really not. But that's something that makes it really fun, because we are working on absolutely the cutting edge of post-training technologies, and uh, working with such wonderful people like Archit, Shubham, and Sachin. Uh, so that's something I wanted you all to get a glimpse into. I myself am from Kolkata, and I am in Bangalore for a short while. So if you guys want to meet me up, just ping me on LinkedIn. You can just look me up on LinkedIn. So yeah, that's all from my end, and stay tuned for more cool models in different domains like Vishit Aryabhata. So that's all from my end, and thank you for being such a wonderful audience.
Hi, Somik. Thanks
Hello.
for joining on such a short notice, basically, and thanks for giving such an amazing talk on like LLMs and agents. So a lot of people here are second year students, third year students who want to get into an LLMs or are working on like AI and stuff, but they don't know how to uh, bring it to a greater level. So it's like really great that you have started uh, made this startup and also like working with great companies like PhysicsWallah and also publishing open source stuff. And also congrats on the paper. So recently, if you guys don't know, AthenaAgent also published their paper on Aryabhata 1.0. So like all the technical details about it. So you guys can check it if you want to work on it, maybe fine tune it or something. Uh, now I think we can have a Q&A. So if anyone wants to ask any questions.
Hello, am I
Hello.
audible?
Yes. Yeah.
Okay, so there was a slide regarding agentic AIs. So I just wanted to ask something about context windows when you parse a document through an agentic AI, basically post training. So there is a test benchmark called NHAI benchmark, which is basically needle in a haystack benchmark, which states that even models like GPT 4.1, which has a claimed effective context window of 1 million tokens. Basically, it has an effective length of 16K tokens. So how do you deal with this problem of parsing a document through a agentic AI? Basically, moreover, you can say passing a document through a LLM.
That's a great question. Thanks. So I'll basically say one thing. So first of all, context is all about how effectively basically any kind of when you are building any kind of agentic system or any kind of generative AI system in the software stack. The thing about context is you have to basically utilize it carefully. So context is a limited resource, as you just said that GPT-4o has an effective context window of 16K tokens. So one of the things that you have to take care of is that you just put the context that necessary for the LLM to answer a particular question. There are retrieval augmented generation paradigms like Raptor, there's GraphRag, HippoRag, and a bunch of other paradigms. I recommend that you check them out, read the papers. Uh, these papers are all about engineering what context to get from which document and put to the current LLM calls, so that the LLM can actually deal with the current task without getting sidetracked in the most effective manner. And as you guys might know about Andre Karpathy, he literally has said this thing that the era of prompt engineering is obsolete. The future is about engineering your context. So there are a lot of smart research that's being done by companies like Microsoft, VV8, my former company Race Biases, and a lot of these researches are going on. I wholeheartedly recommend that you check out these kind of state of the art researches. They do not need a lot of inherent domain knowledge, and these papers are really accessible. So if you are trying to figure out ways to effectively engineer what to put into the context of a particular LLM calls in a dynamic manner, uh, just read some of these cutting edge research papers.
Hello. Just a follow-up question. Let's say we have trained an agentic AI on some like query thing. We have to ask a question out of a document. And what if our context limit exceeds the given context limit of that particular LLM? So first of all, we have to basically implement some chunking techniques. So how do we deal with this problem that the LLM already has a reduced context length, and now we have to chunk it and give it to the LLM to extract our query from the article?
So one quick note I would like to mention. Uh, you are not just limited by the context window of the LLM, but also your hardware memory your LLM's memory footprint to utilize that maximum amount of context. So let's just say if an LLM has a 32K tokens context length, it's not always that you might have the GPU infrastructure to store the KV cache of that particular context length, right? Uh, and that's a funny thing. Google has kind of beat everyone at the context length game because they have their in-house TPUs, and they can afford to have those exorbitantly high context lengths without and because they can store those KV cache in TPUs. But yeah, aside from that, that's actually the problem of context engineering. How to effectively chunk out the information that's hidden in your uh, hidden in your documents and present it to the LLMs. You might try summarization. See, chunking is not something that has to be done in a deterministic manner. It can also be done in a fuzzy manner. So you can figure out fuzzy ways, maybe using another small LLM to summarize parts of that document so that the effective redundancy of tokens is reduced, yet the effective semantical meaning of the content is conserved in a slightly smaller token budget. So there are tricks like prompt compression. There are tricks like prompt optimization. I highly recommend that you check out Omar Khattab and his lab's work on this framework called DSPy. Uh, so DSPy is one framework that basically helps you, optimize your prompts for certain metrics, and you can literally put the length of the prompt as a metric, which based on which you can penalize your optimizer. So yeah, there are tricks like this. Basically, you can use just black box optimization tricks you can just use to reduce the effective amount of content that you are sending into your chunks, that you are sending into the context window of your LLM.
Thanks for giving such an in-depth answer, Somik.
Thank you.
I also had a question. So, like, I've had this question for like 2 years at this point. So, as we know that you guys are working on post-training of LLMs, but see, all the companies that are outside India, so they are SF based, so they are working on like pre-training of LLMs, pre-training of diffusion models. Even though like stable diffusion and flux, these things exist, there are still like companies trying to put out something. So there is no, to my knowledge, there is no startup or a company in India which is trying to do this. So do you think that this is a worthless thing that we don't have, like, is we can just give an excuse that we don't have enough compute, or like, is there any benefit to doing pre-training as a startup or a company? So like, although I like work in academia, there is it's very difficult to do it in a lab-based setting. But what about like in a industry setting? What's your opinion on that?
Okay, so there are two questions actually hidden answer your query inside your query. I'll answer them one by one. So first, let me clarify something. You just said like there's no company in India that are working on pre-training, and that's not true. There are companies like Servam. There are companies like Ola Krutrim who are actually working on pre-training, and the reason they are working on pre-training is because they have the resources first of all, and resource doesn't just equate to how big of a GPU cluster you have, but resource also equates to how experienced engineers and researchers you have who can actually utilize those GPU clusters. So uh, basically, yes, there's a lot of value in terms of pre-training, but think of it like this. Our startup's philosophy is not the problem of pre-training. We do not actually want to compete in that particular vertical. Rather, we want to make our expertise in post-training specifically, and it's not just for LLMs. I personally am working on post-training recipes for diffusion models like Flux, Pen image, and even autoregressive image generation and video generation models. But you know effectively, what the problem that we are trying to solve is that a lot of companies that are based out of India and abroad, they want to have, use one of these foundation models for their very specific niche task, but they're unable to because the model doesn't have enough understanding of that particular domain or that particular type of problem. JEE problem was one of that, which we aim to solve with PhysicsWallah. We are currently working with a couple of other customers and clients whose specific problems we are trying to solve. Uh, and these problems are, we basically need to solve them, and we cannot just solve them using pre-training or running after AGI or ASI, artificial general intelligence or artificial super intelligence. So essentially the gap in the market that we are trying to fill or cater to is the requirement of artificial narrow intelligence. So this model that we shipped for PhysicsWallah, it serves a very niche pedagogical requirement, but it's still required nonetheless. So yes, let's just think of AGI as something like one reasoning model which has a couple of specialized other reasoning models which can take care of certain other tasks basically. And vision is one of such things because if you think carefully, modern vision language models are also not as good as traditional vision language models. They are not as fast and they're not as accurate, especially in terms of grounding outputs, in terms of bounding box coordinates or pose estimation coordinates. So yeah, think of AGI like this: like if it has a visual cortex, it maybe has access to models like YOLO or RFDeter or one of those state-of-the-art small models as a tool. If it wants to solve a math problem, it has access to models like Aryabhata as a tool. So essentially, it's all think of AGI as not just one huge brain, but as a nervous system. So AGI is going to be a combination of artificial super intelligence and artificial narrow intelligence. The thing that we are focusing on at Athena right now is artificial narrow intelligence.
Yeah, thanks for the answer. Like, yeah, definitely. Like, in as you said, like engineering the context, and I think the idea you're talking about is like LLM OS by Karpati. So yeah.
Yes.
Does anyone else want to ask questions? Are there any second year students who want to ask something? Even if it's not technical, if you want to ask advice about like your professional life, your how to get into ML. So yeah, just feel free to ask. Somik has great experience in working at multiple industries and startups. So maybe he can provide you with some info.
So, hello.
Hello.
So, as you mentioned, you are working with PW from quite a while. So, how did PW approach you? And being at a startup, what is your like daily, day-to-day experience working in a startup?
Okay, so two questions. First of all, I am not much familiar with the PW project since I joined AthenaAgent recently, and since even the end of July, I was working at RoboFlow, and I literally joined AthenaAgent after Aryabhata 1.0 was shipped. So that's a question I would recommend. You can reach out to Sachin on LinkedIn or X and just maybe DM him and you can ask him. But the second part of your question, what's my day-to-day life at AthenaAgent? So it's a little different from my previous jobs because my previous jobs I was working as an ML engineer, and but as at AthenaAgent I'm working as an ML researcher. So a lot of my time goes into literature review. I read a lot of research papers. I make notes. I brainstorm with my team, especially with Sachin, Archit, Shubham, and Chinmay, and we try to come up with strategies on how we are going to approach a particular problem that our customer needs or one of our client needs solving. So we brainstorm a lot, we do a lot of literature review, and let's just say 80% of my time is in coding. So I just open up VS Code and I just write code. So it's a lot about writing code, binging a lot of weights and biases logs. Yeah, I still use weights and biases because it's the best tool for experiment observation and management. Yeah, it's a lot of binging logs. It's basically Uh, and you see the final checkpoint. There are so many intermediate checkpoints that we have lying on as artifacts at our personal storage. uh, we experiment a lot. We observe the results of these experiments. We benchmark those intermediate checkpoints, and we figure out, again, brainstorm ways to solve, make things better. And all of these we are doing at using deadlines. Yeah, always under some certain deadlines. So yeah, the work at times can be a little stressful, but it's fun. Let's just say, like, let me emphasize that most out of everything, the work at AthenaAgent is fun. We are not expanding right now, but at some time in future we do plan to expand. So if you guys ever want to work with us, just hit Sachin or myself up on LinkedIn.
Okay, thank you for the answer. One follow-up question. How's your life different from like working in a big tech company like IBM versus working in a startup? Which one would you prefer more?
Working at a startup. The earlier stage the startup is in, the better.
The earlier stage one.
Yes, absolutely. Maybe as I grow old, I would start preferring later stage ones or big tech ones, because let's just say life at big tech is less fun, but it's more stable. So uh, like it's not like some one fine morning you will find out that the project you were putting a lot of love on has been shelved, and you are instead of being assigned to a different project, you are being let go. So that might happen in a startup, depending on what kind of company you're working at, what kind of vertical you're working at. But usually these things are less frequent in big tech. Things are usually more stable. In my opinion, you go to big tech once you know either you are working on something really that really requires a lot of budget, or maybe you just need some security or stability in your life. Then I would recommend you go to big tech. But other than that, I personally prefer startup life because I have a lot of agency on my work, and I operate on this weird uh, paradigm of development called obsession-driven development, or ODD, if you were for it. So there's very little scope for doing ODD in a meaningful manner in a big tech. So my experience at IBM was, with respect to that, was horrible. But the people were really amazing, and the people, to be honest, in all the companies I worked were amazing. Uh, but yeah, at any day, I would say, AthenaAgent is definitely is the most exciting chapter in my career so far.
Yeah, as you mentioned, like Sachin is very helpful. Even I approached him on Twitter, and he like answered all of my questions and agreed to this talk. So we'll send the Twitter and LinkedIn links in the group, so you guys can also like bother them with your questions. Uh, okay, anyone else? Any more questions from the back?
Hello.
Hello.
Okay, one last off-topic question.
Sure.
So, as you know, with the rapid increase in LLMs and all of these things, the hard coding is disappearing these days. So, what do you think is the future of machine learning with respect to this? Because these days people don't have the like motive to go in out there and find the problems, bug in the code. Mostly, we take the code, give it to Gemini or other LLMs, and we get our answers and we like process our tasks. So, what do you think is the future of machine learning and all of these things with respect to this problem?
Okay, so let me be clear with respect to the culture of vibe coding that you're talking about. Vibe coding might be useful in some very specific cases in the software engineering world, or at least I'm basically talking. Let's think of software engineering as two different paradigms. In one case, things are deterministic, and in one case, the things are stochastic. So machine learning is, by its nature, ML development, or whenever I'm writing some code for any kind of ML project, there is an element of empirical research and stochasticity in the code base itself. So vibe coding is useless for me personally. The kind of work that I do, I don't think I'll be able to. If I get into trouble, or if find a bug, I don't think vibe coding is going to help me out any day. But if you are into, development of more traditional kind of software, in which maybe you are using LLM tool calls, or even AI powered software or something like that, specifically when you're developing software applications, uh, maybe the full stack side of things, you might find vibe coding useful. I actually do use Cursor and Windsurf a lot for my personal projects, because I have, spent all my career working in ML, writing PyTorch, JAX, and TensorFlow. So I don't know much about things like React or React Native. So if let's say if I have an idea, and I want to prototype it quickly, I do really find these vibe coding tools useful. But if you're worried that, in future all people are going to do is, say prompt something, and, these systems are going to spew out working code, let's just say we are about at least a century far from that kind of a scenario, or it might never be possible also. I personally think it's never possible, because, you know like you yourself said, context is king, right? We have the LLM can act only based on the context it's given, and to produce deterministic result, the prompt also has to be deterministic, covering each and every edge case that can possibly encounter. And you know what that kind of a prompt is called? It's called source code. It's literally the code that you're writing. So instead of writing it in Python or C++, why would you write in natural language? Just go and write it in Python, and it's there. I would say vibe coding is useful for specific scenarios of assisted debugging. I really find that useful in certain cases, but mostly not these kind of agents that spew out entire projects. They are really not that useful.
Hello.
Hello.
So this is slightly off topic, but if you are aware of the AI 2027 scenario, where it states that AI, like we will reach like general artificial intelligence by 2027. What is your opinion on that? Is it science or science fiction?
It's let's just say these are just marketing PR stunts. Don't be fooled by anything a certain person is saying about Death Stars and stuff like that. Nothing like that is even remotely on the horizon. Uh, Instead, if you are worried about these kind of singularity like scenarios, I wholeheartedly recommend that you read a couple of research papers on scaling laws. Okay, there are the chinchilla scaling laws for language models. There are scaling laws for visual language models. There are scaling laws for even diffusion models. So recently, a paper came out which was talking about diffusion-based LLMs and a new set of scaling laws. So let's just say we are really far away from any kind of singularity, and a lot of work has to be done to get there. And it's 2027 is too unrealistic. Heck, we don't even know if the Raman movie is going to come out in 2027 or not. It can be delayed, and you're talking about super intelligence. No, nothing like that's probably going to happen. I might be wrong. They might be cooking up. I don't know what they could be cooking up, but it's beyond my imagination.
Okay, anyone from it? Hello.
Hello.
I think you were talking the scaling laws in diffusion paper. Was it the one where they compared autoregressive with diffusion models?
Yeah, that very same paper.
Yeah. So, like as we mentioned, like we are nowhere near AGI. So, like as recently with the GPT-5 release, also it was like pretty underwhelming. Like it has been hyped for over 3 years now. So, and like many other papers, even Jan Licken is always like talking about we won't reach there with LLMs. So, what do you think? Like, have the like scaling of LLMs like ended? Like it can't be improved further, or what do you think is the case?
Uh, Probably, I would say, LLMs or diffusion, these individual paradigms, they are not the path to AGI. Any kind of statistical model of human generated content on the internet is also probably not going to get us AGI. Uh, there's a reason that we evolved for millions of years to reach to this point of intelligence. So yeah, like I don't have very strong opinions, but I know for sure that we are nowhere close to AGI. Scaling laws are something which even uh, they used to be the Moore's law with respect to hardware and compute. So now people are trying to come up with the same for AGI. Uh, I really don't have a good answer to your question, to be honest. But let's just all agree that we have nothing to be scared of these machine learning models. And probably a good reason is because the amount of data that's available is flatlining. Like there's a limit to the amount of data that you can mine. And there's in the same diffusion LLM paper, you will find citations to another paper where they say that the amount of human generated data that we have is probably going to be exhausted by 2028. And the internet might be polluted with AI generated content to such an extent that it will become useless to keep crawling the internet. So yeah, data is definitely a bottleneck. Compute also to some extent is bottleneck, but yeah, simply scaling up is not going to crack it anymore, I think.
Yeah, I think I agree with your assessment over there. Also, like one last question from my side. So, at Athena Agent, are you guys working on multimodal LLMs, or recently have you started anything around that?
We might in future, like see, there are a couple of projects that are a work in progress, and since they are collaborations with different other labs or customers, I cannot reveal what I am working on right now. Uh, let's just say multimodality is something which I personally myself focus on a lot. Uh, but that's the extent to which I can truly answer your question.
Yeah, that's understandable. So, uh, I think we can.
Someone actually asked a question through chat, like how a beginner in LLM can explore the field for someone who's into just like second year.
I'm actually going to tell you about my journey. So I started, uh, you know, uh, I started coding when I was in at sixth standard, and I wanted to get into the business of computational graphics. Uh, so when I went into college, you can understand KIIT. It's a tier three college. It's no IIT, though we call ourselves king of IITs. But the first thing I understood is computer graphics is a topic which no one in India can probably guide me on. So I chose the next most exciting thing, which was computer vision, and I just followed all the resources that were available online at the time. The courses by Andrew Ang, the Stanford course, the Stanford machine learning course by Andrew Ang, the deep learning.ai course by Andrew Ang, the original machine learning course that was taught by Jeffrey Hinton, in which you need to code using GNU Octave. Uh, then he talks about Boltzmann machines in that course, by the way. Yeah, these courses. I don't think they are outdated. They might be outdated in terms of code, but not in terms of the concepts. I definitely recommend that you take some of these courses. Uh, and most important of all is, this is a very fast moving domain. So you have to first of all take a decision. You want to be an ML engineer or a context engineer. So an ML engineer is someone like me who is actively working on developing the models. I work with technologies like PyTorch, JAX, uh, Accelerate, Hugging Face transformers, and stuff like that. But if you want to get into an AI engineering or a context engineering profession, you basically have to have very good fundamentals for core software engineering and computer science. I think because essentially it's software development, but with stochastic components, which are machine learning models. So you first take a decision which domain you want to pursue, and accordingly start reading papers, read research papers. Like I cannot emphasize on this more. Like read the original AlexNet paper, read the original paper on ResNets by Kai-Ming He, read the original transformer paper from 2017 by Ashish Vaswani. uh, if you are into context engineering, go ahead and read the original DSPy paper, which talks about black box optimization. Read the papers on HippoRag, on GraphRag, on Raptor, these paradigms. But do read research papers, read technical blogs, and the third component to any successful career in engineering or research is building. Just build, contribute to the open source. Go ahead, pick your favorite project, check what issues are there, pick up issues, submit PRs. It will be difficult at first. Slowly and slowly, as you get into you know a project, you start becoming a domain expert. And this open source journey is something which I have been highly active since 2019. I have been contributing to Keras. I have contributed to Keras for a long time. And as part of Asian Biases, I have worked on a lot of open source projects. My entire job description at RoboFlow was open source engineer. So open source is something which I really recommend you take a look at and build. Like that's all I can say.
So thanks for the talk, Somik. Thanks for joining on such a short notice. If you guys didn't know, like originally the talk was supposed to be given by Sachin, the CEO of AthenaAgent, but he wasn't here today. But thanks, even though I'm really glad that you were here because you have a lot of open source experience, even like weights and biases, which almost I think everyone who works on ML has to use it someday or uses it. So this talk was mainly on like the intro about LLMs and agents. What can we do with reinforcement learning? But if you guys are interested, we can also have future sessions where they can talk about scaling up things or like how to work in production, how to work on ML ops. So let me know if your guys are interested in that. And yeah, thanks for joining.
Thank you, everyone.